This is Algebra 2 at Trig. We're working on quadratic functions in standard form for the second day. We're going to talk about how to graph standard form. So the first thing we're going to do is talk about the axis of symmetry. The axis of symmetry is always found by negative b over 2a. We've talked about the line of symmetry before. You know your vertex is going to be on that line of symmetry. So to find your line of symmetry, you're going to take your axis of symmetry, which is this calculation here, and substitute it back into your equation. And when you do that, that gives you the y value of your vertex. Now you can create a table from that, and we can calculate values, or we can just use our parent function and stretch it for us to figure out the other points on the graph. So what we can talk about here is, you notice that this is in standard form. Y equals ax squared plus bx plus c is in standard form. And that's the format that this is in. That's different than the vertex form or intercept form we've talked about in the past. So to find this axis of symmetry, we're going to use the equation negative b over 2a. Well, your b value is the one with the x. So in our case, we'd have negative because that's part of the formula. Our b, it's negative also. So we have to use parentheses around that. 2 times a. Our a value is next to the x squared. So our 2 is next to the x squared. So this is 2 times 2. So that tells us our line of symmetry is actually at 2. Now we have to figure out where on our axis of symmetry our line of symmetry is located. So we're going to plug our 2, our x value that we found. We want to know where it exists for the y in our equation. So that's 2 times 2 squared, because it's 2x squared. 2x squared. 2 times 2 squared minus 8 times 2 plus 7. So we don't say 4 squared, we have to say 2 squared. So this is the number 4. 2 squared is 4, times 2 is 8. 2 times 8 is 16. And then you're 7. 8 minus 16 is negative 8, plus 7 more gives you negative 1. So we're down here at a y value of negative 1. So our vertex is the x is 2, and our y value is negative 1. You could make a table out of that. And from there, you could put your x is 2 and your y is negative 1. And you could calculate other values to the right and to the left of that. So to fill out that table, if it was interesting to you, you would need to take the 3, when x is 3, and you need to plug that into your equation. And that would make 2 times 9, 18 minus 24. That's going to be negative 6 plus 7, which is 1. So we know at 3 we're going to be up at 1. We could do that again. We could do when x is 4. And that's when we use y equals 2 4 squared minus 8 times 4 plus 7. Just plugging it into our equation. So you got to say 16. 16 times 2 is 32 minus 32 plus 7. That's going to put us at 7. 1, 2, 3, 4, 5, 6, 7. So that's one way to do it. Now you could go over, since you know this is your vertex, you could also do the other side. 1 and negative 1. Oh, 1 and 0, why not? You could do negative 1, but 0, that would be the logical values over. But let's talk about a shortcut. This has the value of 2. We know the parent function would be 1 over 1 up, because 1 times 1 is 1. 2 times 2 is 4. Those are the parent function locations. Neither of those are where we are on our graph. We need to be here. Those are twice as much up. So over 1 up 2. Over 2 up 8, because you had to go twice the 4. And then we can reflect these across your line of symmetry. So reflecting across would give us this point at 1, 1 and 0, 7. They are going to be 1 to the side, and not 1 times 1, but times 2. 1 times 1 times 2 is twice as far up. Not 2 times 2 equals 4, but times 2. 4 times 2 is 8. That's 8 up from the negative 1. And there's your graph. Okay, let's try that again down here. I'm not going to use a table this time. You're welcome to. To find my vertex, I have to do negative b over 2a. Negative 4 over 2 times a. That's going to give me 4 over negative 2, which is negative 2. I have a line of symmetry at negative 2. So somewhere on my line of symmetry is my vertex. So I figure that out by plugging in the negative 2 back into my equation. So negative 2 squared minus 4 times negative 2, I'm a little tight in here, plus 2. That gives me 4, which is negative, then 4. Negative 4 and negative 2 is positive 8, plus 2 more. So that's 10 minus 4, which is 6. So on my line of symmetry, I'm going to be at 6. So my vertex is going to be negative 2, because that was my negative b over 2a, comma 6, because that's what happens when I plugged in my negative 2 into my equation. 1, 2, 3, 4, 5, 6. Now, where are these other points we know of? Well, one very quick one, we always know that this is called your y-intercept. When x is 0, we have a y-intercept. Even when we have 0 squared and 4 times 0, these are crossed off, so you're left with 2. So when x is 0, y is 2. We know that for sure. So some people like to put that on a graph right away. That's fine. You know there's another point because you're 2 away from your line of symmetry. You can be 2 away from your line of symmetry. That's called a reflection point. We reflected it over our line of symmetry. Are there any other points that we know from sure? Well, we know the parent function should be 1 over 1 times 1 is 1. But we're going to go in the negative direction because we're timesing it by a negative 1. So we go down 1. 2 over from your vertex. 2 times 2 is 4. We're going to go in the negative direction. 1, 2, 3, 4. Exactly where we said it was going to be. 3 over. 3 times 3 is 9. We're going to go in the negative direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me recount that. 1, 2, 3, 4, 5, 6, 7, 8, 9. I thought that was going to land off the grid. That's okay. Okay, we can reflect this so we know it's supposed to go through that point. And there's our graph. We didn't need to use a table. We didn't need to do a whole bunch of these extra calculations. If you know the parent function is 1 over, and 1 times 1 is 1, 2 over, and 2 times 2 is 4, we can graph that out very quickly. You just need to understand that in this case, we go in the opposite direction. We don't go up, we actually go down. We don't need to times it by anything. It's not narrower than normal. This graph was narrower than normal because the A value was a 2. So our domain is all real numbers because we can plug any number we need to into our value of x. Our range, we're up at 6 and we're going down. You could use interval notation of negative infinity up to 6. Don't forget to always use your smaller number first, your larger number second. So negative infinities of y's all the way up to the 6 as your largest. And behavior, as x approaches negative infinity, as we look to the left on the graph, which way are the arrows pointing on the left side? They're pointing down. They're pointing to negative infinity. And as we look to x's that are getting bigger, as we move to the right, which way is that arrow pointing? It's pointing down as well. So it's pointing to negative infinity. For a quadratic, it's always going to be pointing in the same direction. It's always going to be pointing, in this case, down because your A value is negative. Otherwise, it's both up, like we had in this one when the A value was positive. They both point up. Do our comparison. Remember, our parent function is y equals x squared, so we're comparing that to our parent function. Well, we see that there's a reflection. The graph is now opening down compared to up. So we say that this graph is reflected over the x-axis. This graph, after we've done the calculations, we can finally see it. It is translated 2 to the left and 6 up because our vertex is 2 to the left and 6 up. We did not have any stretching because our A value is not a 2 or a 3. We didn't have any shrinking because our A value is not a half. It's not a fraction. We didn't need to make a table. You could have picked values. You probably would have picked -1, you would have picked 0, you would have picked 1, and you would have calculated, by plugging them in, you would have calculated what these points were. It is so much faster to use 1 over 1 down, 2 over 4 down, 3 over 9 down. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. because the parent function is the x value squared. Okay, let's try this one. Here, we could consider this to be standard form. Y equals 2x squared. We don't have a b value, so the b is 0. And our c value is -5. You could consider this to be standard form. Now, you could also consider this to be vertex form, where you don't have an h value, and your k value is -5. You can do it like that. So you already know where your vertex is at. It's at -5. If you didn't know that, you could have tested it. X equals -b over 2a. We know the b value is 0, so -0 over 2 times 2. That's 0 over 4, which is just 0. So we have our line of symmetry running right down our y-axis. And when we plug in 0, 0 squared is 0. 0 times 2 is 0. I get -5. So I know my vertex is at 0, -5. It's quicker to think about it in this format. My y-intercept is at -5. I have no b value, so there is no translation happening. It's just straight down. Now from here, you could either make your table and plug in a value that's x is 1. Plug it in here. 1 squared is 1 times 2 is 2 minus 5 is -3. Or you could do your parent function, which is 1 over 1 up, but we're going to do twice that amount, 1 over 2 up. And look at that, 1, -3. 2 over 4 up, that's your parent function, but we have to do twice that amount. Do another 4. And because this goes so quick, you can do another location. 3 over, what's 3 times 3? From your vertex, 3 over, 3 times 3 is 9. Times 2 is 18. Okay, that might be off the chart. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the parent function, but times 2. 10, 11, 12, 13, 14, 15, 16, 17, 18. So you now know that your graph is going to go all the way up. You shouldn't cross this line of x is 3 until you get up here. I'm going to stop at the edge of my graph. You can go all the way if you like. Now you can recount those if you like. 1 over up 1 times 2. 2 over up 4 times 2 is 8. 3 over times itself squared, which is 9, times 2 is 18. You could do that, or we can just use these reflection points. 2 over, 2 over. That would be 3 over, 3 over. And that's where your graph is going to be pointing towards. So your line of symmetry we knew was x equals 0. If you wanted to do your -b over 2a to verify that, you could. And when we plug 0 into that, if you like to test your points, you're welcome to do that. But you don't really need to. 0 times 0 is 0. 0 times 2, so you get -5. So your vertex is 0, -5. I like to put a V next to that because that's my vertex. And my end behavior as x approaches negative infinity, the function's going to do something. And as x approaches positive infinity, the function's going to do something. Let's take a look. When we look to the left, which way is the graph pointing? It's pointing up. So it goes to positive infinity. And to the right, it also points up. So it goes to positive infinity. That's your end behavior. Now, when we found the vertex here, we saw that it had a low point. It's the lowest point on our parabola. That's called a minimum. And it has a minimum because the a value was positive. When it's positive, the graph opens up. It's going to have a minimum value. So here is a standard form. We see that the a value is -2. I know that that means the a value is less than 0. Therefore, it's going to open downwards, so it's going to have a maximum. The graph is going to open downwards, so it's going to have a high point. Now, where do we find this high point to be? Let's try it. We first got to do our line of symmetry. Axis of symmetry, or LOS, line of symmetry. -b over 2a. -10 over 2 times a. That's going to be a +10 over a -4. Oh, makes this a little tricky. We can reduce that to 5/2. So that's our line of symmetry if we were to graph it. But we just want to know what this maximum value is. Well, it happens on the line of symmetry. So let's plug the line of symmetry back into our equation. And we're supposed to be squaring it, because our equation is -2x squared. -2x squared. When you square a fraction, you square both the top and the bottom, so that's 25 over 4. When you multiply an integer times a fraction, you can multiply the tops of the fraction. You're going to get a positive, because a negative times a negative is a positive, so 10 times 5 is 50, divided by 2. We have 7. I can reduce this right here. That gives us -25 over 2 plus 50 over 2 plus 7. So when you subtract 25 from 50, you get 25. Now we need to add that to 7. Well, you know denominators have to be the same to be able to add fractions. What does the numerator need to be to still represent 7? If the bottom was twice as big, then the top has to be twice as big. This has to be 14. So your maximum value is going to be 39 over 2. That is your maximum. Not the vertex value, just that. The vertex is at -5/2, comma, 39 over 2. But when we answer the question, what is the maximum value, it is 39 over 2. Here we have it in vertex form. Vertex form gives us an a value, gives us an h and a k. The k and the h and k are your vertex. So we have a vertex at 11, 28. It's going to be a positive 11 because our formula is x minus h. This is x minus 11, so h is 11. So that's your vertex. We know that the A value is 4, which means it's a positive, so it's going to be opening upwards. So we have a minimum value. And that minimum value is going to be wherever this vertex is. Y equals 28. So the minimum value is quickly 28. Here we have intercept form. Y equals A, x minus P, x minus Q. To find that line of symmetry, we do that by P plus Q divided by 2. Notice this does not have a B value in it. It is not in standard form. It is not in vertex form. So our P value is 1. Our Q value is actually negative 3. Because it's x minus Q. So x minus what number makes this? So x minus a negative 3 makes it look like a positive 3. So this is negative 2 over 2, which is negative 1. So we have a line of symmetry at negative 1. But we're not graphing it this question, but if we were, we'd draw in our line of symmetry. We notice that the A value is negative 2, which is negative, so this is going to have a maximum. The graph must open upwards. It opens downwards. It has a maximum. So we're going to plug our line of symmetry back into our problem to figure out that location. Negative 2, negative 1 minus 1, negative 1 plus 3 into your equation. Plug the x value into the equation. So positive 4 times 2 is 8. So that is called your maximum. Your vertex would be negative 4 comma 8. We don't care about the vertex. We care about the maximum value. The maximum value is when y is 8. Good job, everybody.